Hi everyone, welcome to the next episode of Azure Mythbusters. My name's Glenn Small, part of the Fast Track for Azure team.
And I'm Will Eastbury, also part of the Fast Track for Azure team.
And today, the myth we're looking at is I can use any cloud data store for my data and services. So Will, really this comes under the heading of just because I can doesn't mean I should.
In another episode in the series, we can talk about this for compute, but we're going to focus around data today. There's a whole stack of questions you should be asking yourself around what you're going to do with your data. What data do you actually need to capture? So this is our kind of tagline. What data does your application store? And we're going to go through a number of sub-questions in a moment and just fill out why we think they're important.
Completely. We've discussed requirements before, and it's very important to understand what the requirements are and what you're working with before you actually start making decisions. So the first one, unstructured, semi-structured data, with many different uses here, right?
Yeah, absolutely. So what type of form is your data in? Yeah, is it a data blob? Is it binary images? Is it pictures? You know, is it a JSON document? Yeah. Any sort of flat output from any other system, or like you say, it could be documents that are just going to be served up to an end user, or even like you say, those JSON sort of snippets, XML files, anything there where there's some sort of processing with it. And of course, this would lead you into those kind of Databricks, HD Insight, maybe data warehouse things if we're going to process this later on, or just serve it straight up from an application. Yeah, and all the way back down into kind of, is it classical relational data? Yeah, so kind of in many ways, the relational data one is the one that people default to, right?
Absolutely, it's probably the most common one that you see. It's the database, whether that's SQL Server, Postgres, Oracle, whatever it may be, and you know that you've got a particular problem you are solving. Your data is relational by nature, and it's pretty straightforward. Yeah, if you've got data that's tabular and is quite clearly related by different keys inside an RDBMS, you're probably not just going to export it out, stick it in blob storage. I would really hope not, yeah. Likewise, if you've got blob data, you'd hope you're going to put it in blob storage. Yes, not try and push that into a SQL database and then serve it up in that way. Although it may be an option depending on how you want to use it. Yeah, absolutely. I mean, it's probably worth at that point actually highlighting one of the patterns, going back to some of the other episodes we've run around patterns. And the one around, you don't necessarily have to use a single store. Yes. Yeah, polyglot persistence. Exactly. It can be quite important. One of the areas we particularly see this, is document stores. Right? What kind of documents can you store? And I don't mean, when I say document, a Word document, classically, although you can store that. Exactly, we're not talking those kind of documents here. Yeah, exactly. So XML documents, JSON documents, this is structured data, but maybe it doesn't adhere to a fixed schema. Exactly, the structure's different, you want that flexibility, and quite often you need a faster access pattern and throughput from there as well when you're working with those discrete pieces of data. Yeah, absolutely. It's not denormalized data, but it's still kind of, there is a clear structure to it, but it's not the same every time. It needs to be a bit more adaptive, and how you index those and kind of free-form indexing is really, really important. Completely. And this is where obviously you start to see Cosmos DB really starting to come to bear with those use cases. Yeah, absolutely. So we have got, in terms of Cosmos DB, we've got another type of store which we can pick up as well there, There are many, but there's a really, really interesting one around graph. For those, again, those examples of data where you're trying to go through those multiple relationships and understanding, or how is one piece of data there, how is that piece of data used and referenced across other multiple discrete pieces of data within their graph really comes to bear. Yeah, absolutely. And great backdrop we've got here is also actually illustrating a graph, right? A series of points that are connected together. Social media kind of connections and those sort of things, friends of friends. Yeah. Graph really comes to bear in those cases. So again, you could serve that data you could make it work within a relational database. You could try and roll your own within a blob store or data lake or something like that. But understanding how you want to use the data and then picking the appropriate application or product is really the first step, right? Don't come armed with I want to use this particular product because it feels I've not used it before. Absolutely right. So we've thought about what type of data it is. And the next question then is actually, what are the characteristics of the store that we're going to need? So what do I need to do with that data, and what do we actually need to put it into the correct box? Completely. So let's take this first one then. So we're really getting to this. How are we going to query this data?
Yeah.
What's the demands? Are we using it just as staging, preloading? Are we going to persist it and query it?
Yeah, so it's kind of the difference between sticking something into data lake store, for example, where you're going to actually go on demand and load it up and query that in a big batch and chew it up and spit it out, or something like, okay, I've got more relational data and I actually need to query that online.
Yes.
Yeah, or a document with Cosmos, I need to query it instantly and I need an instant response.
So those query patterns really do start to lead you towards picking one product over another. There's a number of factors to consider there, but certainly, data lake is a great staging environment. I don't know entirely how I want to process that data, what I'm going to do with it. I may leave it there for a little while, but when I need to fast load that into something like maybe it's SQL data warehouse, maybe it's processing that on mass with Databricks. Something like a data lake to bring that in on demand is ideal in those scenarios.
Yeah, so you're touching on retention there, which actually gives us a nice segue into our next question.
Exactly.
So how long do we need to have access to that data for?
Yeah.
And actually that has a kind of secondary impact on your data volume and the potential cost to store it. So
completely. Hot storage versus cold storage, that has a price point that comes with it as well. It starts to lead us into questions around performance. If I do need to query data that is archival, and again, these are things where cold storage in a data lake for those rarely used queries, or maybe we've aged out data from a relational database into more longer term storage there. Those kind of patterns make sense. Wouldn't necessarily make sense to have everything pushed into flat text into a data lake when you've got thousands of people querying it every single second.
Yeah, so you might have a smaller window of data that's sitting hot, and a kind of retention or rehydration type process that can pull stuff back in from an archive.
Absolutely.
Which brings us nicely on to the next question. So that's a really key characteristic, right? Do I need all of my data to be online, or can I handle a little bit of latency for historical queries, for example?
The data retention piece, this may be due to some sort of policy or legal requirements. It may simply be that you're managing costs and typical access patterns and you want to optimize that hot front end. And you've got some kind of process that looks over the data, maybe on a monthly or a yearly basis, and is simply transitioning data between SQL data warehouse, managed instance, something like that, back into data lake storage.
Yeah, so coming back to that polyglot persistence.
Absolutely.
So obviously that kind of does have an impact on cost, actually, what we've just described. So one of the key things that I see day in, day out when I'm working with customers, actually across all areas in Azure, is picking the service that matches your cost profile. Yeah, so obviously services which index everything are tuned very, very highly for high levels of throughput. Services which just store blobs are primarily optimized for cost.
Yes.
Yeah, so choosing that kind of, this is how much data I've got, how can I estimate that? And what your budget pattern looks like can be really, really important.
Absolutely. Factoring in those requirements, the usage of how you're going to do it, and then what's the right option that I use within my budget is a very important step. You may go for, I've said this a number of times, a data lake store with flat files in there. It's not going to cost a lot to store that, but if actually your access patterns require a high level of concurrent queries, you're going to suffer potentially from performance on those queries. And so what are those requirements around performance, and is that going to meet your needs?
Yeah, and then you go to the opposite end of the scale where you're hard provisioning performance and saying, well, no, we need this guaranteed level.
Absolutely. Okay. Which could then become very expensive if you're storing terabytes of archival data. It's available at a finger click, but maybe someone only requests it once a year.
Yeah, fair enough. So it's tuning that setup. Okay, cool. So speaking about tuning and people requesting and accessing data, that's another key consideration, right? So who can connect to that data and where are they located? Yeah, and where will they do it? Where are they sitting?
It's almost the same set of questions, isn't it? But now not related to the local application, if you will, but any of those third-party applications, maybe it's other end customers that are connecting in through some sort of API or whatever to access that information. What are their requirements, or what are your SLAs that you're signing up for them? And how do you factor that in?
Yeah, absolutely. I think that brings us pretty much to the end of our series of questions, though.
I think it really does. And as we said there, just because you can do something doesn't mean you should. And it really coming back to those requirements and understanding what is the type of data you're storing, how do you need to use it, and what's the most appropriate product then to facilitate those needs. So there we go. We've looked at what kind of data are we storing, how do we want to use that data, and what's the right product or service in Azure to let us access the data in the appropriate way for the kind of data that we're working on.